lesson 1.8, the coordinate plane. So the coordinate plane is going to be one of the things you're most going to see in math. It's everywhere in every single math you're going to take in the future. So you start off with two axes, and like it's called the y-axis, which is the vertical direction. This is the y-axis, and the x-axis, which is the horizontal direction. Note that these arrows are here to note that it goes on forever. It's like a number line, but instead of also going in the horizontal direction, it goes also in the vertical direction, or negative vertical direction. This is the x-axis. So you have it's divided into 4 quadrants. You see how this is like a quadrant, this is a quadrant, this is a quadrant, and this is a quadrant. So let's call them quadrant 1. It's in Roman numerals. Quadrant 2. Quadrant 3. And then quadrant 4. Quadrant 4. So you're gonna have different points. So let's say this is 1, reaches all the way to 5. This is 5 over here. Let's say this is 2, 3, 4, and then you're gonna have -1, -2, -3, -4, -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You're also going to have -1, -2, -3, -4, and -5. Note that down is negative and left is negative. Left is negative in the x-axis and down is negative in the y-axis. So one of the main points in this whole coordinate plane is the origin. The origin, it's like origin, where everything starts, and this is the point of intersection between the y-axis and the x-axis. Let's write this here. Origin, which is 0, 0. 0, 0 is an ordered pair. I'll explain what that is in a second. So an ordered pair is any point on the x-axis that it's a point on the x-axis. So let's say you had a point over here. You have a point here. An ordered pair is when it's a point in the coordinate plane that you write down as the first number is the x-coordinate and the second number is the y-coordinate. So let's say x-coordinate, y-coordinate. So in this case, the x value of p would be -3. So p equals -3. The first pair is the x-coordinate, and then the y-coordinate, -1, -1. This is what an ordered pair is. So brings us to our examples. Example 1. Example 1. Give the coordinates of the point. So it gives us a graph with certain points. This is the graph. Note that this is the y-axis and this is the x-axis. So it gives us, here we have point A, which is 1, 2, 3, 4. These are all singles. This is 1. This is 1, 1, 2, 3, 4. This is -1, 1, 2, 3, 4. This is 1, and then 1, 2, 3, 4. This is -1 over here. So gives us point A and point B. Point B is 3 to the left and 2 up. So this is B. And then A is 2 to the right and 4 down. 2 to the right, and this is a 1. Just know that. 2 to the right and then 4 down. So it gives us to give the ordered pair for A, and then for B, for B. For A, it would be the x direction. So you have 2 in the x direction. I'm noting it like this. Just note you have 2 in the x direction for A, so 2 in the positive, and then 4 down, which is for negative 4. And then B, the x value is 1, 2, 3, 3 to the left, so it's -3, and 2 up, +2. So this would be the answer. So, example 2 is it is giving us certain points and telling us to plot them on the coordinate plane. So it gives us point A, which is 4, 1, point B, which is 0, -3, C, which is -2, -5. So if we make a coordinate plane over here, this is the Y, this is the X. So if we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, -1, -1, 1, 1. So if we have to plot 4 in the x direction, so 1, 2, 3, 4, 4 in the x direction, and then 1 up. So 1 up, and this is 4 in the x direction. So this is going to be A. For point B, we're going to be 0 x direction, so it's going to be here. We're not going to move anywhere in the x direction, and then 3 down. 1, 2, 3. B is going to be over here. C, we're going to go -2 in the x direction, so 1, 2, and then -5 down. So we're going to go all the way down to -5. This is going to be point C. This is off example 2. And example 3 is about a biologist who collects advanced data about mass and length about 8 rainbow trout. So like the mass and the length of the rainbow trout. So we have to make a scatter plot of the data, and they give us a scatter plot of the data, and we have to describe it in a graph. So they give us a bunch of ordered pairs, and we have to graph them. The ordered pairs are 405, 715, 360, and 557, 413, 754, and 395, 584, 247, 184, 280, 248, 265, 223, and 351, 506. So as you can see, the x is the x-axis. It's the length of the rainbow trout. Length in millimeters, always include unit. And the y is the mass of the rainbow trout, which is given in grams. In grams. So what you would do in this case is, which would be better to do with a graphing calculator or online, would be to graph this by making an x-axis and a y-axis and then plotting the points, and you get an overall estimation of like how the relationship between the length and mass of the rainbow trout. So as length increases, you get to see how mass increases overall. This is why you have a lot of data, so you see the overall trend of how they're increasing, the slope at which they're increasing in. The graph would wind up looking something like this. I didn't include any numbers for the sake of time, because these are very precise numbers, but you could put them into a graphing calculator and get it like very precisely. But we could see the overall trend of how it increases in this direction. Like as length increases, mass also increases. Once it gets to a certain length, the mass starts to increase like exponentially, sort of like it starts to increase at a very high rate, is what I'm trying to say.